Welcome to lesson 4.4, which is all about factoring complex trinomials. What makes a trinomial complex? Well, our a in our standard form of ax squared plus bx plus c, our a is a number other than 1. So in the last lesson, all our simple trinomials always started with x squared. Now we're going to have a number in front of x squared, a coefficient. So, first off, before we get into that, a couple patterns we may have noticed when we were doing our factoring before. And if not, these are good to know because they'll help you out. If we have something in the form, trinomial in the form of x squared plus bx plus c, and everything is positive, well, this tells us that when we're factoring, we're looking for two positive numbers. Two positive numbers that, when multiplied together, equal c, and when added together, equal b. If we get x squared minus bx plus c, so c is positive, but b is negative, this tells us we have two negative numbers. Two negative numbers, when multiplied together, become positive, so that's why c is positive. But when added together, of course, are going to still be negative, so that's why b is negative. Our third pattern is x squared plus bx minus c. C is negative, so we know that one of our numbers is going to be positive, the other one's going to be negative. And because b is positive, the larger number must be the positive one, because when we add them together, b's got to be positive. In this last one, we have x squared minus bx minus c. So bx and c are all negative. Since c is negative, we know one number is positive, one number is negative. And since b is negative, that means our larger number is negative and our smaller number is positive. When we add them together, we are still negative. And remember, always check for a common factor before you start to factor a trinomial. If there's something common that we can pull out of all three terms, we do that first. All right. So, when we factor complex trinomials, we use a process called decomposition. And decomposition just means to break down, or the state of being reduced into original elements, or breaking down a process into subprocesses and activities. And so this is what we're going to do to our middle term of the trinomial. We're going to decompose it or break it down. So the first step in factoring complex trinomials is a bit different than when we factor simple trinomials. So we'll take a look at all the steps here. Remember, when we have a trinomial, it's always in the form of ax squared plus bx plus c. And so step one is we're going to multiply a and c together. So a times c will give us a number. Now we need to find two numbers that multiply to the product of AC and add to B. So multiply A times C, and then we need to find two numbers that multiply together to give us A times C and add together to give us B. I'm going to use an example shortly on. After this, I just want to show you the steps first. Step 3 is we're going to decompose or break down the middle term with the two numbers that multiply to AC and add to B. So what we found in step 2, we're going to use that to break our middle term down. Step 4, we're then going to find a common factor for the first two terms, and then find a common factor for the second two terms. And then finally, we'll simplify to show the two binomials, the complex trinomial factors too. So let's see an example so this makes a little bit of sense. Our example here is 3x squared minus 5x minus 2. It's an ax squared plus bx plus c format. So 3 is our A, minus 5 is B, minus 2 is our C. So our first step is we're going to multiply A times C. So 3 times negative 2 is going to give us negative 6. Now I want to find two numbers that multiply to negative 6 but add to negative 5. So I can think about those. Okay, I need two numbers that multiply to negative 6. So because they multiply to negative 6, we know that one number is positive and one number is negative. They're also going to add to negative 5. So once again, our larger number is going to be the negative number. So two numbers that multiply to negative 6, add to negative 5, are going to be negative 6 and positive 1. Negative 6 times 1 multiplies to negative 6 and adds to negative 5. So we're going to break down our middle term, this negative 5x, using negative 6 and 1. So let's see what happens. Decompose or break down the middle term. So 3x squared minus 6x plus x, which is our positive 1, minus 2. So minus 6x plus x is still minus 5x. So we haven't changed our formula here. We still have the same formula. It's just we've broken that middle term into two other terms. Once we've done that, what we're going to do is we're going to take these first two terms in green. We're going to find a common factor and pull that out of both those terms. And then we're going to look at the two terms in purple, and we're going to find a common factor for those. And our goal is to have the same things left over. So I'll show you what I mean by that. Find a common factor for the first two terms, then find a common factor for the second two terms. Well, my first two terms are 3x squared minus 6x. So I'm looking for the greatest common factor I can pull out of there. Start with my coefficients, 3 and negative 6. I can factor out a 3. And then I have x squared and x. So I can also factor out an x. So I'm going to pull 3x out of that. And then I'll have, I pull 3x out of that. I'm going to have x minus 2 left over. Now I'm going to look at positive x, or 1x minus 2. Well, I can't pull anything out of that. That's as simple as it can get. So what I'm left with is 3x times x minus 2 plus, in brackets, x minus 2. And this plus is really key. We want to leave that there. Our goal when we're doing this and we're factoring our first two terms and our second two terms is we want what's left over in the brackets to be the same. If you notice x minus 2 and x minus 2, they're both there. That's perfect because in our final step, we're going to pull x minus 2 out of both of these terms because it's common to both of them. So we're going to common factor that. So we'll have x minus 2, and then that's multiplied by 3x plus, remember this is a phantom 1 there, so maybe I'll just really quickly. Uh-oh. Never mind, my drawing tools are not working for some reason. But we'll just pretend that this here is a 1. We just don't write that 1. So x minus 2, and what's left, 3x plus 1. X minus 2, 3x plus 1. Those are the two binomials that are that factor down from our original equation, which was 3x squared minus 5x minus 2. And we can prove that x times 3x is 3x squared. X times 1 is x. Minus 2 times 3x is minus 6x. So that'll become minus 5x. and minus 2 times 1 is minus 2. And that's exactly what we started with. All right. So, example 2, I'm not going to talk so much about the steps as just show you the steps. Steps are going to be the same. I'm going to first multiply A times C, then find two numbers that multiply to that, and add to my term B here. Once I've done that, decompose my middle term, find common factors for my first two terms, find a common factor for my second two terms. What's left over in my brackets should be the same. And then I just write my two binomials that I have. So I'm going to start off here, and I encourage you to maybe pause the video and try this one on your own. And then once you've done it, just start up the video again and see if you got it right. So, first step, A times C. Well, that's 6 times negative 5, so that's going to be negative 30. So I need to find two numbers that multiply to negative 30, but add to positive 7. And so I can go down my list. What multiplies to negative 30? Well, it could be 1 times negative 30. It could be 2 times 15, but neither of those are going to get me to 7. What about 3 and 10? Ooh, that could work. And it needs to add to positive 7, so I know that my 10 has to be the positive number. It's the larger number. So if B is positive, my larger number has to be the positive one. So my two numbers are going to be 10 and minus 3. And so I'm going to write those instead of my middle term of 7x. So 7x will be replaced with 10x minus 3x, which still equals 7x. So we haven't changed the integrity of the equation at all. So 6x squared plus 10x minus 3x minus 5. Now we're going to do the same thing we did before. Find a common factor for our first two terms, and then find a common factor for our second two terms. So 6x squared and 10x. Well, I look at those, and for my coefficients, I see I can pull a 2 out of both of them. And I've got an x squared and an x, so I can pull an x out. So I'm going to pull 2x out of my equation. 2x, which is going to leave me with 6x squared divided by 2x is 3x. And 10x divided by 2x is going to be just 5. So 3x plus 5. Now, I want to keep in mind that for my last two terms here, when I factor these, I want what's left over in my brackets to match 3x plus 5. And I have minus 3x minus 5. So the only way I can get that to match is to factor out a negative 1. That'll change my signs in the brackets, and then what's in my brackets is going to match. So I'm going to factor out a negative 1. I'm now left with 3x plus 5. So we're going to have as our binomials 3x plus 5 is one of them. And then 2x minus 1 is going to be the other binomial. So 6x squared plus 7x minus 5 can be factored down to 3x plus 5 times 2x minus 1. Last example here, we have 4x squared minus 12x plus 9. Once again, I encourage you to pause the video, and then when you think you have the answer, start it again and see if you got it right. So our first step, we need to find the product of A times C. In this case, that is 4 times 9, which is going to give us 36. I need to find two numbers that multiply to 36, but add to negative 12. I see C is positive, but B is negative. This tells me I'm going to have two negative numbers. All right, what's going to multiply to positive 36 but add to negative 12? Well, we can go through all our factors. What multiplies to 36? Well, there's 12 times 3, but that won't add to negative 12. There's 8 times, oh, sorry, there's 4 times 9. 4 and 9. No, that's going to be negative 13, so we're not quite there. What about negative 6 and negative 6? Negative 6 times negative 6 equals 36. Negative 6 minus 6 is going to be minus 12. So that's our numbers, minus 6 and minus 6. So that's what we're going to use to decompose our middle term. So now we get 4x squared minus 6x minus 6x plus 9. Factor what's common in the first two terms. In this case, that's going to be 2x. So we pull 2x out. We're going to be left with 2x minus 3. And now I look, and I've already given away the answer down here, but try not to look at that. We want to factor something out from our second two terms, minus 6x plus 9, and keeping in mind that we want what's left in our brackets to be 2x minus 3. So if I look at that, I can pull out a 3, but it's got to be a negative 3 because I need my signs to change. So I'm going to pull out a negative 3, and that's all I can do. So I'm going to factor out negative 3. Well, negative 6x divided by negative 3 is positive 2x, and 9 divided by negative 3 is going to be negative 3. So what am I left with? Well, 2x minus 3, that's what's inside my brackets, and 2x minus 3 is left outside my brackets. So I could leave it like that as 2x minus 3 times 2x minus 3. Or I could even, well, let's just do that. Or I could say that this is 2x minus 3. Let me just get my exponents. Oh, there it is. Whoops. Uh oh. What did I just do? Ah, there it is. I did not mean to make it a fraction. So that can be rewritten as 2x minus 3 squared. Sorry, that took a little bit longer than I anticipated, but 2x minus 3 times 2x minus 3 can just be rewritten as 2x minus 3 squared. All right. On that note, you've got a little fun project here for homework. Don't worry, you don't have to submit this, but it's just a good way to get used to factoring complex trinomials. I hope you enjoyed that lesson. If you have any questions, as always, feel free to either join me in live office hours or just send me an email and I will help you out as soon as I can. Take care.